Welcome to today's WiDS Datathon University Challenge winners panel discussion. My name is Valerie Elliott. I am a program director here at WiDS, and today I am also joined by our WiDS Datathon collaborators from Anna Bauer's Women's Brain Health Initiative and also Child Mind Institute. So I'd love for them to each introduce themselves. Ariana, Amy, and Nina, if you'd like to give a quick introduction.
Yeah. Hi, everyone. It's very nice to be here and nice to see you all. My name is Arianna Zonazzi. I am the Open Science and Research Collaboration Specialist at the Child Mind Institute, which is an independent nonprofit that is focused on transforming the lives of children and families who struggle with mental health and learning disorders. And we are also the ones that provided the data set, which is the Healthy Brain Network data set for this challenge. So my role as CMI involves leading open science initiatives and driving data sharing efforts, as well as fostering collaborations between internal and external stakeholders. And yeah, I'm very excited to hear about the winners' approaches and solutions. Yeah, looking forward to this. Thank you.
Yeah, so my name is Amy Kuzieski. I'm a professor at Weill Cornell Medicine and Cornell University, and I'm the co-director along with Nina of the AI Core for the Women's Brain Health Initiative. So this is a foundation that is funded by the N.S. Bowers Foundation, and it's really focused on trying to identify how things that happen in a woman's life can impact brain health, like pregnancy, menopause, menstruation, dementia. And sex differences as well. So a lot of my research is centered around that. And that's kind of why we reached out to Ariana with her beautiful data set and WiDS with their lovely reach that they have to the women in data science community. So it's great to be here.
And hi, everyone. My name is Nina Miolan. I'm a professor at the University of California, Santa Barbara. And with Amy, I'm a co-director of AI for the Women's Brain Health Initiative. So my research is targeted it's in AI for science, in particular AI for neuroscience, and in particular the neuroscience of women's brains. So my lab develops methods that target small data sets, AI methods that can work for small data sets. So we develop methods such as geometric deep learning, topological deep learning, equivalent deep learning, and the like to extract knowledge from this scientific data set. Very nice to meet you all, and congratulations for participating and winning the Datathon.
Excellent. Okay, so just to set the stage for today's call, this year we had a WiDS Datathon University Challenge where all of the different students participated from around the world with the support of their university instructors and faculty members. I know some names here on the call, so I see some instructors have joined to listen in, which is great. In the University Challenge this year, the students analyzed fMRI data to analyze how brain networks develop differently across males and females throughout childhood development. And so it was a really great challenge, and I want to thank all of you for participating and congratulate the winners for your achievements. And so today we will hear from each of the three winning teams. Each team will take about 10 minutes to present their solutions, and then we'll have a dialogue and Q&A with the WiDS Datathon team here. If you have questions for the winners as well, feel free to put them in the chat, and we'll see if we can get to those. If not, the winners can help with some of that in the chat as well. Also, during the call, if you can please just keep yourself muted so we're not interrupting the students, that would be much appreciated. And we will get started. So first up, we will have the first place team from Team AI Synergy from, I'm going to botch this, but Gheorghe Asaki Technical University of Asai, located in Romania. And so I will hand it over to the first place team to introduce themselves and share their solutions with you. So why don't you go ahead whenever you're ready.
Hi, my name is Theodore, and we are presenting with Maria the solution for this competition. Let Maria to talk about the first part.
Hello. Firstly, we are very excited. Okay. Is the sound good?
Yes,
Okay.
thank you.
Well, firstly, we are very excited to be here and to have taken part of this challenge. My name is Maria Gabriela Fodor, and I'm here with my teammate Theodor and we formed the team AI Synergy. I'm gonna go briefly through the agenda. Firstly, I'm gonna go through a background of ourselves, then a summary of our approach, and then Theodor will present the feature selection and engineering and the training methods following. And after that, I will go through some important findings and a simplified model. Next slide, please. Okay. We are first-year master students at Artificial Intelligence from Faculty of Automatic Control and Computer Engineering, Gheorghe Asaki Technical University of Iași. And we have graduated Information Technology in 2024 from the same faculty. Next, please. Now going on to the solution. The main training methods that we used and that obtained good results were random forest, decision trees, KNN, feed-forward neural network variants, and stacking techniques in the end. Secondly, for the feature engineering part, this was pretty standard. We handled missing values on the feature data, and then we applied data standardization and encoding. And the tools we used were Python, scikit-learn, PyTorch, and matplotlib for data visualization. Next, Theodor is going to present feature
I'm
engineering.
starting to present this part of feature engineering. For the data preprocessing, we mainly focused on the metadata preprocessing, and these are the steps dealing with the outliers, scaling numerical features, handling features with missing values, and categorical features encoding. We used one-hot encoding for this. When we dealt with outliers, we used the interquartile range measure with 0.1 lower bound and 0.9 upper bound thresholds to check if one feature column has outliers. From this research, we found that the BMI feature has outliers. And after which we plotted the BMI feature distribution. This is the plot before the processing, and this is after. You notice that there are some two instances of the data that were clipped into the range in order to make sure that we don't have outliers into our data. We scaled the numerical features. We applied the standardization technique, which will help us to use the data into the training methods that are not scale invariant, like neural network or something. The training methods that are scale variant are decision tree, random forest, but these are kind of limited. So this is very necessary. After the scaling numerical features, we inputted the features with missing values because our data provided us missing values. This is the distribution of the missing values both on the training and the test dataset. As you can see, BMI has the lowest missing value percentage, and the race and the parent notification has the highest missing value percentage. What we have done here is that we removed these two columns, race and parental education. These two we removed, and with the rest of the data from here, we used the kind imputation with the number of neighborhoods equal to 5, separately on numerical and categorical features. This was our decision because this empirically we observed that this provides better results. For the training methods, we used the random forest, the gradient boosting regressor, the feed-forward neural network, the simpler one, and the variant with the residual blocks. So, for the random forest, we used the default scikit-learn hyperparameters, and we achieved 0.73 RMSE and 0.45 R squared score on cross-validation. The gradient boosting regressor, we achieved 0.68 RMSE squared and 0.52 R squared, still on cross-validation. The random forest takes the longest among these four models, but gradient boosting the same, but it's not it takes a little bit shorter. And the neural networks, the simple one without the residual blocks, we search the hyperparameters using the grid search cross validation because the default parameters wasn't enough. And you notice that it takes shorter than the random forest and the gradient boosting regressor. This achieves 0.65 RMSE and 0.56 R squared, a little bit better than a gradient boosting regressor on cross validation. And this is the hyperparameters for which we found. And these are needed for the final model, which is a stacking method. The neural network with residual blocks achieves better performance than the simpler one. The same, we search the hyperparameters using the grid search cross validation. Has the same training time and achieves better performance, as I said. 0.61 RMSE score and 0.61 R squared. With these four models, we submitted the results into the Kaggle platform, and we noticed that this is not enough, and we needed to obtain a better performance. So we've come with an idea to use a stacking technique, which help us achieve better prediction score. These four base estimators have the same hyperparameters as described here. And on the final estimator, we use the rich CV model with the default hyperparameters, which helped us a little bit more to achieve this performance. Maria will tell you afterwards what we obtain and some interesting things and findings.
Okay. On to some important and interesting findings. Theodor, next slide, please. Firstly, sometimes we observe the experimentally, then that sometimes missing values cannot be inferred effectively. So a strategy such as removing those attributes with a high percentage of missing values was leading to better results. Secondly, while a single model might provide most of the accuracy and scores closer to stacking methods, overfitting in our solution is further mitigating by using ensembles. And another very interesting observation is that we did not obtain the best results by using as meta classifiers the best individual classifiers, but by introducing also some lower scoring classifiers, so that we obtain that stable and consistent model. Next. Next, we have an illustration of a correlation matrix on some numerical features. And it is highlighting that the correlation between those is overall pretty low. So even if we tried for reducing the training time to eliminate some of these attributes, that would have led to informational loss. So we decided to keep all of them. Next. Okay. Now, those are one of our best submissions on the private test set. So as you can see, the difference is not that big between the first submission and the second one. And the first one is a much simpler model. It's just the best classifier. The residual multi-layer perceptron regressor model achieved a score of 1.93. But the full ensemble of 4 regressors and a meta model reached 1.87. Next. Now, to make a summary of all the presentation, we explored neural networks and variation of those. We focused especially on low resource models as we didn't have a lot of resources available. And we tried diverse pre-processing techniques. And also we realized that well-tuned lightweight models can rival heavy ones. And next. Now on to some advantages and fun aspects of how the competition went. Our teamwork was an essential aspect, as we did parallel experimentation with different models. While I was trying some kind of neural network, Theodor was trying another one, and we compared results and so on. Also, this is the first time we worked with real-world data or disclosed real-world data. And the variation of the data was also interesting, as we had matricial data, we had categorical and numerical values on the metadata. And last but not least, fine-tuning models and seeing direct performance improvements was a very rewarding process for us. And now on to the Q&A part. If you have any questions.
Thank you very much.
Let me close. Okay.
I have one question. First of all, congratulations, Marianne, for the results of the presentation. It was very clear. Excellent work. I have a question on I think the standardization of the feature. So you explained in well, Theodore, saying, yeah, that the metadata is carrying invariant. Can you say exactly how to keep the standardization? Did you put the mean to 0 and the standard deviation to 1? Or did you also try to match the distribution of each feature to a Gaussian distribution? Like how exactly did you do the standardization?
The standardization was a simple transformation from any data to standard normal standard distribution between -4 sigma and 4 sigma. With 0 centered, it's not between 0 and 1. That is the normal, the scaling one. And
Awesome, thank you.
okay, thanks.
Thanks.
Any other questions for the team?
Yeah,
Yes, please.
if I may ask, yeah, first of all, congratulations. I'm curious, when you look at the different models, do you see like if there's difference between like how these models perform differently, different subgroups of these subjects? As in, like, is there some particular group that your residual MOP performs better than, say, your linear regression, for example?
Can you repeat, please, the question? I didn't heard. Was network delay?
Yeah. So my question is, do you see if a particular, let's say, take a particular model like your MLP, is there a particular subgroup of subjects, let's say female, that it performs better compared to another model, or like do the errors distribute evenly in a sense?
I think we didn't analyze this aspect. We didn't look into the missed predictions or how much was the error on that, but it's a good feature research topic.
I have
Yeah.
one finding that I can say. When I did present the slides, you notice that the BMI distribution is a little bit has a long tail around on the higher the BMI values when you did so this. This can be if we apply the logarithm transformation on this feature, we can obtain better performance on the these values that are more rare, like higher BMI, or that is one data analysis aspect that I noticed.
Cool. Thanks a lot.
Thank you. Well, congratulations. Great job done. And at this point, we will move on to the next team. So well done.
Thank you a lot.
You're welcome. Next up, we have the second place team, AI for Idiots from VN UK Institute for Research and Executive Education at the University of Da Nang, located in Vietnam. So I'll let the team introduce themselves and present their solutions. All right, great. Now we can see it. Perfect.
Okay. Good morning, everyone. We are pleased to share the methodology and process that led our team to achieve the second prize in these competitions. And agendas. Our presentations will go through 8 sections from background to discussions. And our team is composed of Tâm, Long, Hiếu, and myself is Nguyệt. And while we come from different academic and professional backgrounds, but we were united by 4 core values that guided our work: is learn and support together, curiosity, learn from mentors, and apply research skills from other last project. Before we dive into the technical details, let's quickly revisit to the competition's main objective to frame the challenge we were solving. All right. The main goal was to build a model that could predict a person's brain age using resting state fMRI data. To do this, we were provided with 2 key types of information for each individual. First is the functional connectome matrix, and the second is some basic metadata. So how did we approach this challenge? Here is the pipeline we've designed to tackle this problem. We started with the raw data and moved into the comprehensive reprocessing phase, which included is handling missing data, transforming it into usable format, and final data check for quality. Once the data was ready, we entered the core of our project, training our deep learning model. Crucially, our process were iterative, and we would evaluate the model's performance and use this insight for improvement. This iterative refinement allow us to steadily increase our model effectiveness and leading us to our final results. And now, next sections is data visualization presented by Tâm.
Right. So in this sessions, we began by looking at the distributions of numerical factors and specialize in B factors, internalizing, externalizing, and attention score.
Oh, sorry, you're muted.
Yeah.
Maybe.
So specific colors like B factors, internalizing, externalizing, and we investigate the gender difference, why the distributions for males or and female are similar across like externalized and other health dimensions like B factors, internalized and externalized. So there was generally more male participants than the female participants. So for the missing values, we employ the random forest based imputations, which effectively handles the missing stages primarily found in category features like genders, ethnicities, and parents' educations. So we then used a random forest registers to assess the feature importance in predicting the brain age. Like you can see that BMIs are as the most important features, followed by the externalized attentions, B factors, and internalizing factors. So demographic factors like the race and ethnicities have a less influence, and hedonics have a minimum impact in this chart. So finally, we visualize the functional connectance 200 by 200 correlations matrix from resting state fMRIs, and this shows how different brain regions interact. And this matrix interactions between different brain regions and was factorized to serve the input stress to predict the reflection models. So these visualizations have our model decisions and highlight which features were most relevant. And in the next sessions, EU will take us to the data deep learning model.
Okay, so before we check the data into the deep learning model, we have to check the data and see some column metadata have lost some values. And we want to combine a metadata and train to training deep learning. So we must make sure that the metadata is clear and no missing value. And we use random forest regressor for a numerical value such as BMI, factor, or patient. And we use random forest classifier for non-numerical short access, study size, ethnicity, and hardness. So dealing with missing data give us more data to train and value. Better understand the gap in the data. After handing on the missing value, we are going to transform the data. With numerical data, we basically normalize them in standard. We do that because we want to control the value, domain, and avoid outliers values. So next, with non-numerical data, we will encode them by using one-hot encoder. Make sure that the deep learning model can understand. But we have some problem. The one-hot encoding method strictly makes some nodal in deep learning model test or not active because the vector one-hot many happening zero value. So we highly use for supposing one-hot encoding is better for training and smoothing. And finally, we apply a random masking for the FC matrix. That's meaning we hide some value in the vector. So we want to gain a better generalization. And in conclusion, with standard normalization, we control the data scope, avoid extra value data. We adapt using one-hot encoding to make the sign of the numerical feature and avoid a node of that in during training. And we apply random masking for FC vectors to improve the generalizability for the model and avoid overfitting. And the next session, Long will explain about architecture of the model.
Okay, so in this training stage, we're going to employ an autoencoder which is a deep neural network in order to learn a deep, meaningful representation of the FC matrix combining with other categorical variables. So at first this autoencoder serves two purposes. First is it's trying to reconstruct the FC vectors, which is the upper triangle. This is from the upper triangular matrix. And also it's going to combine with other categorical variables, which is going through the smoothing process in order to concatenate in order to predict all the individual values such as age, BMI, and FS factors. So we are trying to doing that to make the latent representation to learn the meaningful features so that we can reduce the dimensionality better in order to fit into the other models in other process as well. We want to include that during the training loss, we are going to schedule it by multiple tasks because in autoencoder we're doing 4 tasks, so that we must have the appropriate weight in order to make the model specify in a correct learning order. Okay, so next after training of the latent space, we're going to concatenate with the BMI and also with the other factors, such as internalizing, externalizing, attention score, etc. So we're going to concatenate to make a full vector so that we can train it by using other machine learning models. In this case, we're going to use the XGBoost, the light GBM, also the rich regression. So during our experiment, we're finding that training with too many machine learning models does not improve the accuracy as well as we thought. So we're going to use only just 3 models to predict the age, and then after that we're going to use a meta model, which is rich regression, in order to correct our prediction. So in the second stage, I'm using the other cross validation process in order to precisely evaluate the model according to each split, so that it does not make the model biased. So that is our idea of training in the second stage. About for the training configuration, so we're going to train with 500 epochs, although we're going to save the model with the best performance, and also we're using the learning rate of 0.001 with optimizer is ADEM-W. So because in our experiment we find that our model is very overfit, so we have to put the dropout rate to 0.3, although we try to increase the dropout, but it degrades the model performance, so we're going to keep it at 0.3. So about the loss function, in the first stage, I said that we're going to use the composite loss, so we have to manage all the loss functions as accurately as possible. So here we're going to evaluate based on the prediction of age, the factors, the BMI, and also the regression. But I mean that the difference here is that we have to schedule the loss coefficient. So at first, it's going to prioritize in reconstructing the FC, the functional connecton vectors. But after that, it's going to give more priority to the age prediction. So it can give our model very robust. And using the evaluation metrics, we're going to use the root mean square error, which is in default from the organizer metrics. So we use that to evaluate the discrepancy between the age prediction and also the age GAU2s. And after that, we're going to visualize it by using a TSNE so that we can see the correlation between the graph truth with the prediction. So you can hear, so our prediction is clearly in a line, but however, due to in a target, we just only predict about the age from 8 to 21. So there's some small variable, so it can affect our performance. So, but I think that using TSNE visualization is a good way to evaluate. Yeah, about the experience gains inside this competition, we found that first is smoothing the one-hot encoding and also masking the FC matrix. The FC vectors can also do a huge difference because in this competition, the scope of the data set is quite small, and also the distribution of the FC matrix is not that big. So we're trying different ways to augment the training input so that it makes the model very robust in generalization. And second, we think that the test distribution is maybe different, so that because of that, we need to use the generalized model better. And the most important thing we learned is that the stratified sampling is very important, because during the experiment, I see that there are several different study sites, and in those study sites, they have different equipment in trying to capturing the fMRI images in order to transform into the matrix, so that we need to stratify sampling correctly, so to ensure that every training split, training batch, it will receive the same sampling, so makes the training much easier. And about the things that we learned from the competition, we find that the most fun aspect is that we actually have ways to explore the processing techniques in the beginning. But the thing is, we have to go through the trial and error processes. So which is also very fun, but also very hard way, because we make so many mistakes and during the first training. And also the big challenges we find is that overfitting, because our model using a deep neural network and also autoencoder. So the overfitting is a big problem, although the root mean error in training set is just only like 0.02. But however, in the evaluation, it's like 0.6 or 0.7. So it makes the problem more difficult. So maybe in the future, if we have more time, we can try to spend time clearly more on the feature engineering part in the beginning. And also we find that the graph-based neural network is not very effective, although that the functional connector matrix can be theoretically be used with a graph neural network. But however, when I try to use it, it's not very effective. So that we have to change the method back into the autoencoder and also with the machine learning and assembly. So that is our report for this competition. So thank you for listening.
Thank you so much for your presentation. What questions do we have for the team?
I actually wanted to congratulate this team. I really love your presentation and your approach. I think you also make a great point about the site. So you really focus on a great aspect, an important aspect of fMRI data. I actually have a question about your approach itself. I like that each of you presented a different part because it really reflects also the fact that you have different background. You said at the beginning. And I'm curious about how your different backgrounds really helped you solve this challenge and whether you faced other challenges that instead made you learn something that you didn't know before.
Good question.
So, yeah, if I start with different background, so for me, I will sharing like I am a data driven marketing in the UK, and I have the explores for a data driven decisions making the course from a university. So that course helped me to provide some more the knowledge about data visualizations, and I can contribute it into our teamwork. And how about Long and you?
For myself, my background is business administration. It's totally is about business, but I have a little bit interest in data, so I think this competitions is my opportunities for me to research more about data science and something about technologies and about my research can help my team to get some information to handle our challenges. And about Long.
Okay, so for me, my background is data science, but I also pay attention to a little bit about mathematics because I think that mathematics had an impact a lot in trying to interpreting the machine learning models and how to evaluate them. So I do a lot of research about like machine learning and especially deep learning. So that is my strongest point that I can contribute to the team progress. So what about you?
Oh, I'm everyone. I'm you. My background is engineer, and I'm so very interested in the model, and I want to apply AI in the real world. So I make AI day by day. So if I have opportunity, I want to try with the modern AI, and so thank you.
Thank you. Yeah, great job. Congratulations again.
Excellent job. Well, thank you all for your wonderful presentation. And last but not least, we have the third place team, also from VNUK Institute for Research and Executive Education, located in Vietnam. So I will hand it over to the third place team to introduce themselves and share their solutions.
Okay, so we are team 3 VNUK Data Cam in Binh Chilling, and we're gonna introduce you to our presentations. So first, we're gonna take you through our agenda. So we're gonna talk a little bit about our team's member backgrounds and together with some summaries we have, and we're gonna present some feature selections and engineering, as well as some solutions overview. And in the end, we're gonna show you some important findings that we have. So a little bit of our background. So for the first one is me, Uyên. So currently a majors in digital business management at VNUK. I'm currently pursuing as a business analyst intern at AIIBN. And she's also having the same major as me and at VNUK too. And she's currently serving as a customer service intern at COP. And then we have Kai, he's majors in data science, also at VNUK, and he's an AI intern at Consent AI. and he's really passionate about AI and data. And lastly, we have Jin. His majors in computer science and engineering, and his work as a DevOps engineer at Everpoint. So for our summaries, so here's a quick summary about our work in this competition. So in order to improve the model capabilities and generalizabilities, we adopted model stacking approach, which gonna help stack many different base models in order to get to our final predictions. And we also discovered that the BMI column is the most significant features that contribute to the age predictions results alongside with other functional connectivities data. And we use a lot of tools and libraries in order to support our work, such as Pandas, Scikit-learns, XGBoost, and PyTorch. So next up, we're gonna have on introducing feature engineers, selection engineer.
So for the feature selections regarding to regarding to the features that our group selected for training our models, so we first move columns such as study site, handedness, parent 1 education, parent 2 education, and this is because those columns are explicitly irrelevant to predicted A, and besides, including them might capture noise as patterns which can hinder our model performance. Therefore, we decided to drop these columns and we didn't see much drop in our performance. And we used the remaining features for training models, including BMI, FC data, sexes, ethnicity, and races, etc. And we also did some basic feature engineering for our data for feeding them into the model. First, regarding the missing values, we decided to impute categorical with a no value instead of mode or any random value. And this can help prevent imbalanced categorical data where there's more samples with a particular categories. As BMI is quite left skewed, we imputed it with median values. And lastly, we use KNN imputer to impute missing values for FC data. And we also pre-process some columns such as BMI, sex, ethnicities, race, and more specifically, we standardize BMIs and one hot encoded for those in categorical columns. For the next one is presented by Kai for the solution overview.
So our solution was model stacking. So why do we do so? Before that, we had examined the feature importance of each model in predicting age. Regarding rich, so the magnitude of BMI is significantly higher than other features, which can be explained by the higher the BMI index of a person is, they might be older than those with lower BMI index. And rich also combines attention and internalizing index alongside with FC data in order to predict age. We might also see the same pattern in gradient boosting where BMI is in the top one, but it isn't as significant as in rich. It also combines the FC data in order to make prediction. So we believe that when we stack many different models together, they might learn different patterns in the data, which can help our solution becomes more generalizable and robust more to the noise within the data. So this is the general overview about our solution. So from the original data, we would create out-of-fold prediction from 5 folds by stacking 12 base models, which were hyperparameter tuned through cross-validation. We then use those out-of-fold predictions in order to feed as features to feed into meta model to get the final output. The reason we choose the kernel rich as our meta model because it achieved the highest cross-validation score. So with this approach, we did achieve some interesting result with our first submission, including 5 folds only, using the same base model. On the public score, it was 1.60, but I was really suspicious about the score because when I tested, it was around 1.89, 1.90. So that's the reason why in the private score drops down to 1.90. And the submission too is just a little bit in the pre-processing step. but I try tenfold, but it dropped. The public score dropped a little bit, but when it comes to private score, it only around 1.92. And the interesting thing, I thought that when I give split more votes, it means I give more data for the model to learn. But it turned but the performance for the 5 votes with the same pre-processing step as submission 2 achieved a better private score compared to the submission 2. Even there's a little bit drop in public score. I think it is because I wasn't careful in splitting the data where the outflow prediction of the 5 votes could maybe match better than the 10 votes. So therefore, it achieved better performance on the private score. Next, Jing will share with you some important and interesting findings that our group discovered during the competition.
Hello. So there were like a few things that like didn't work out first. So firstly, we decided to like reduce the dimensions of FC data as it had like 20K features. However, like this approach disrupted the fine-grained signal from the FC data, which is like very useful for predicting the age. And besides, we also tried using autoencoder with the purpose of getting the latent space of SC data, but it didn't work as PCA, but it could be explained in the same reason as PCA as PCA where useful signals were kind of disrupted. And let's talk about what we learned through this competition. There are like 3 main things that we found to be quite valuable for us in the next Datathon journey. So firstly, remove explicitly irrelevant features like study site, parent education, etc., to avoid capturing noise patterns. And we don't hesitate to like remove these columns as this might hinder our model performance on real-world data. And secondly, stacking too many models might actually do more harms than good. And we noticed that in all of our submissions, the private score of submission with less models were higher. And last but not least, always start with simple method first. This would basically form a baseline for us to try even more complex methods later on. And yeah, another really strong point that we learned is that like friendship is pretty much everything. Like we did this together by being friends, basically. Yeah. So let's go to Q&A.
Awesome. I actually have a quick question about the number of models you included. So you said that the ones that you submitted that had like a fewer number of models tended to perform better on the private score. Did you do anything with like trying to figure out which models to include and which not to include? And did that matter, or was it just a random selection of them that you left out?
I noticed that during a test, because the meta model is kernel rich, so even if the model if the output prediction of any model is irrelevant to the age prediction, then I think kernel rich will eliminate them out. But I couldn't understand why when I stack more models, then the performance on the private score starts to decline, and I couldn't
It's probably,
understand.
I would guess it's overfitting, right? That's
Yeah, I think
probably.
it's stacked, but what if the current eliminates all the feature out because it's still.
It did eliminate them.
Yeah, when I checked the coefficient, it did eliminate some of them, but I don't know the score drops. And there's also one thing that I can understand in theory. Normally, we would do it means data pre-processing on the data that we train only, but not on the data that we try to make prediction. But originally, I did pre-process everything, and then I'll do the model stacking. But this could introduce data leakage. But then I switched back to doing data pre-processing for each fold during the model stacking, but it results in poor performance compared to, I mean, just slight performance drop. So uh, compared to the pre-processed first, then we do model stacking. So I'm pretty questioned about that.
Thank you. What other questions for the team? Do each of you have any goals or things you're looking to pursue after your studies?
After our study at the university?
Yes.
So currently, I haven't thought about that, but my goal is just to finish my university as soon as possible and trying to maybe do more things about AI engineering. If I have found, it means I think I will just cover more about things that I really want to learn more when I go to work. And through that, I will may pursue higher education like a master or PhD. So that's what I'm really looking forward in the future.
Wonderful. Any other teammates have any things that they're looking to pursue either during or after your studies?
I might be like unemployed for a while, so I might as well practice to be like a stay-at-home dad. But the problem is I don't even have a partner. But like that's all the future. That's totally fine.
What about the other two teammates?
So
sorry,
for me, my okay, sorry, my cameras didn't work, so I can't put on my videos. But right now I'm about to move to my 4th year, so I think my near future goal is just trying to finish my my internships and then trying to graduate in terms. And I'm also thinking of trying to learn in the higher educations, but I'm still wondering about which fields I'm going to pursue. So I think maybe after my graduations, I'm going to try to work in different aspects, different fields, trying to figure out which one I want to do. And then I'm going to try to study higher education in that specific kind of field in order to like strengthen my foundations knowledge.
So for me, I'm not very clear about my future direction yet, but I just wanted to finish my university as soon as possible. And as for career, if it's related to data, it's my better, but I just want like to complete my university subject as soon as possible.
Excellent. Well, we wish you all the best in the completion of your studies and focusing on that. And, you know, as you go through your studies and finishing up your courses, I know you'll figure out what direction's best for you. Any other questions for this team? All right. Well, thank you to all the students who presented today. We really enjoyed hearing your findings and your learnings in this year's university competition. We hope that you continue to stay involved in WiDS and our future Datathons. Are there any comments that Ariana, Amy, or Nina that you'd like to share as we close out?
Just thank you for all the presentations. They were lovely. Yeah, very nice.
Yeah,
Congratulations again.
Thank you. Yeah, I would just
Uh,
say congrats again.
Yeah, I hear a lot.
Thank you.
All around. So thank you, everyone. That concludes our call. And
sorry.
oh yes.
Yeah. Yeah, I just want to say thank you so much, WiDS and all the professors for organizing this challenge. It's pretty rare for students to get a chance to deal with this sort of data, real life data. So, this is like a really great entry point for many of them to sort of to be exposed to more opportunities and more challenges that they might not be able to encounter in school. So yeah, thank you very much.
Yeah, you're welcome. Well, thank you and all of your support to the students. It's because of the instructors and the faculty members and all the work that goes on behind the scenes to help give that support and encouragement along the way.
Okay, I just want to share a little bit. Part of our team. So I think that this competition is very great for us because it is provide us the actual opportunity to deal with the real world data, which includes a lot of noise and it's very hard to deal with. Although you just put like a very big model like a deep neural network, but you cannot show it works 100%. You have to do exactly the feature engineering. But I think is about like how I have a question like how can we grow, like how can we optimize our solutions better, like how to do better feature engineering in the FC matrix is also a question that I can have like after this competition, so that maybe after this I will try to deep dive into the field in order to understand it better, so that like maybe I can have like a good published paper on that, or maybe like we can do some more research on a women and female brains, and not just that, but also understand about the neuroscience, the psychology. Thank you.
Wonderful. Well, I love your passion for the topic. Definitely keep us informed. If you're looking to do some extra research or publications around this, I'm sure Ariana might like to be connected with you, maybe. Definitely keep us informed and what things what topics you might like to pursue. If there's interest in this area, then we love learning about that and hearing where you go next with it. All right, everyone. Well, thank you. Have a wonderful rest of your day. Thank you for joining.
Thank you. Bye.
Thank you.
Bye.
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 Bye, everyone.